This is going to be our second lesson, continuing the unit of vectors. We're going to talk about the angle between two lines. So let's consider two lines like the ones that are drawn right there, L1 and L2. And let's assume that line 1 has an equation given by R1 vector equals A plus lambda D1, and L2 has equation R2 equals A2 plus lambda D2. And it is our job now to try to figure out what is the angle between the two lines, this angle right here. So what are we going to do? We're going to think about what that equation of the line is saying about each of the lines. So for R1, what the equation of the line is saying that we have a starting point A1 and a direction vector given by D1. So that vector D1 actually can be represented right here, D1. And then my second line is represented with a starting point A2 and has a direction vector given by D2. And that D2 can be represented, let's say, here, D2. Remember, these two vectors are arbitrary. They just have to go in the direction of the line. Now, what happens? What do I see? I can see that if I conveniently locate my vector D1 and my vector D2 in that position, joining them together on the intersection of the lines, assuming they are intersecting, but also just in a visual position where it is convenient to visualize that angle theta, then what I can do is remember our definition of the dot product. Remember that the dot product of two vectors, A dot B, is going to be the magnitude of A times the magnitude of B times the cosine of the angle between the two vectors. Now, in this case, we have two vectors that are both direction vectors of the lines. So if I use my dot product, I can calculate what that angle theta is going to be. So I'm just going to do the dot product of D1, and I'm going to multiply it by the direction vector D2. And this should be equal to the magnitude of D1 times the magnitude of D2 times the cosine of that angle theta that I have right there. So what that means for us is that theta is going to be the arc cosine, or the cosine minus 1, of the dot product D1 times D2 divided by the magnitude of D1 magnitude of D2. Okay, so this should be a very easy way for us to find that value of theta. Let's apply it to one example. Let's assume we have our equations are given by R1 is given by the vector 1, 0 plus lambda parameter 1, 1 direction vector, and R2 is given by the vector 1, 1 plus parameter direction vector 2, 1. So in this case, if we wanted to find what the angle between these two lines is, R1 and R2, then what we have to do is just take the direction vectors, say D1 is vector 1, 1, and D2 is vector 2, 1, and just do the dot product between those two vectors. So for us, theta, or D1 dot D2, is going to be a magnitude of D1, magnitude of D2, cosine of the angle between the two lines. So let's substitute. D1 dot product D2 is going to be 2 times 1 plus 1 times 1 The magnitude of D1 is the quantity root 2, because 1 squared plus 1 squared in a root. The magnitude of D2 is 2 squared plus 1 squared in a root. That's 5. And cosine of theta. So that means cosine of theta is equal to 3 over root 10, which means, using our calculator, the angle between the lines R1 and R2 is around 18.4 degrees to 3 significant figures.